Let's see. Oh yeah, let's jump in on GD&T problem number three. So let's see. Yeah, this one. Let's see. I've made a little modification here. I actually didn't make it to that one. Just in the description, what I'm really doing. I maybe so I'm going back to the last problem because I have updated this and I'll continue to update them as I get them done. But I have this attached PDF and we're going to recreate the part in Inventor, but some of the CAD files contain errors or are overly complicated applications of GD&T. So some corrections in GD&T controls have been changed on the new Inventor drawings. So I'm starting to upload both of these drawings, kind of where we came from. I do view this as almost like a, you know, could be an in-house revision or update to files, right? That you could be, here's an old CAD file. We want to bring this into Inventor, get the part situated. When you do that kind of stuff, you might have a conversation about the controls that are on that part. If we, do anything need adjusted? And so that's kind of what we're doing here. Maybe I should capture it as a revision one. If I was really doing that in the real world, it would be a total revision and it would all be captured, the changes that I've made here. But that's essentially what's going on. I am kind of thinking through these with a different lens this year and seeing if we can get these a little closer. Um, these GD&T the GD&T requirements of these parts a little closer, and I've dropped a few that are overly complicated. So I'm going to do the same thing here on GD&T problem three, even though I haven't added that to this, but I'm going to add that same little disclaimer there that this is an old print. We're going to update it for Inventor, and we're going to um, just kind of question the GD&T. So I have gone ahead and let me minimize this real quick. Sometimes this takes over my computer. Minimize. I don't need CAD right now. Oh, maximum. Okay, good. I got my taskbar back. Excellent. Okay, good, good. I was just burying my taskbar. So I've already done the modeling on this, so I've just used that drawing. None of the overall dimensions have changed or the placement of the features. So so I've got this thing. I already did the modeling for it. On one note, when you do the modeling for this, if I go back into my sketch, you will find if you apply this dimension and this upper dimension here, if I let me dimension it, it'll be a, I'll accept it. So that is 2865. Yeah, I think that is the same that it's showing on this drawing here, 2.865. If you actually enter that dimension and then try to enter the 60 degrees, you may have a conflict where one is wrong and it might throw your degrees slightly off. So what I chose to do, and why I chose to do that is because I think I have a better version of this up here. Maybe right there. I kind of analyze this, and so even in my sketch, I prioritize the 60 degrees over this dimension here. And the reason is because it's going to become a basic dimension, and it's going to relate to the way we're going to control this surface. And so I am going to keep this one. I dropped some of the other surface controls off of problem one, but I'm going to keep this one. This is the only surface control we have here, so I'm going to keep it and we'll just talk through it a little bit. Okay, so that's big. I mean, that's to me, I made this 60 degrees in my actual model, so that's my theoretically exact dimension. This one can run a little wild. Probably if I pulled the dimensions out a little further or the decimal places out further, we maybe would see a conflict. It's not gonna, yeah, I don't know what anyway, I chose to drive my sketch by that dimension. So this becomes a driven dimension. And that's how I've sketched mine out. And then I've extruded it to that kind of oddball 0.96 thickness. And I've placed mine on my drawing already. So I'm already just kind of ahead of you. You just catch up to this. Um, and I've just used my normal drafting techniques to start my drawing. So I've already gone through it all and kind of like sized and located the things as I normally would. Now let's like refine that. And so I'm going to analyze that. I'm going to like choose the same datums they did, but I'm going to just look at those datums and make sure that they are maybe don't conflict or not in the wrong place. We've caught a few errors, so let me take one last look and let's place datums. So datum A, we're calling our bottom surface of our front view. Actually, it's two separate surfaces, broken up by this feature of size here. And so I could the one thing I didn't look at before I started this, I'll keep this the same, but we may have to be more specific that these two surfaces are considered datum A, and there might be a way to actually call that out. So that's something that's a little more complicated. Remember, our surface has a break in it. So are we calling this datum A or are we calling the entire thing? And I may have to call that out. So I'll look that up. That could be an add-on or part two if I do a little meditation and homework on this thing. But for right now, I'll keep it this, which implies this surface is our datum A. And so all dimensions are really based off datum A that might be in this height direction. So um, then I established datum B, right? Oh yeah, back. Left side surface is going to be datum B. And it looks like I've only established two datums on this. Yeah, so A and B. B, I'm pulling a lot of locational dimensions, looks like for the slotted feature of size. And A and C, or A and B both, I'm pulling, looks like I'm pulling locations for a feature of size on the whole. And I'm even controlling some other surfaces from a datum. And so, okay, I'll just put the two datums on. Let's establish those first. So I'll set the same two datums. It's this one. And let me wiggle this into up and down, maybe a little closer. And I'll move that where I need to move it once I get there. At least I've got it established as datum A, datum B back here on this side. So let's get that thing, datum B. I have my cap locks on. I do good. Datum B is going to be this left side surface. Okay, two datums established. That's all that was required. And let's move on from there. Maybe before I move to the features of size, I'm going. And, oh, the one thing I also did is I'm holding the same decimal equivalent of the. I'm holding the same decimal equivalent of the drawing itself. I did change the decimal equivalent of the 60 degrees, and I guess it's just because it's going to become a basic dimension. So I could hold it to three. I only hold it to two, or I mean one, only because if I look at my general tolerance block, my angular dimensions to the first decimal is where I'm going to hold. Oh, all actual angular dimensions are going to hold to a 0.5 of a degree plus or minus, unless they become basic. So should I change this? I'm going to leave it one decimal. Uh, okay. So yeah, before I jump to this features of size and start doing some geometric tolerancing for those GD&T for those. Well, we need to control one of our surfaces here, I guess, or one of these. This next surface here, the right side surface. So it wants us to control it with an angularity from datum A, and let me see what the tolerance of that was. And I might add, I might control it not. This is 1,000th, so I'm just going to put this to 10,000ths again. And I mean, that might be too coarse, but I'm just going to jump on that side of things rather than be this ultra fine. Um, just for my, just for no real reason, because I don't really know the relationship of the part to something else, but only because I'm just erring on the side of maybe a general tolerance versus some really high critical tolerance here that this maybe would apply. So I'm just going to change this to 10,000. And so yeah, it's an angular geometric symbol here, characteristic symbol. And what do we have here? Oh yeah, controlling the orientation. So we're controlling the orientation of this surface to datum A. But with this. So let's go ahead and apply that. It only applies to datum A. So I'll just point to that, grab it. This is actually one that I do just point to. And yeah, it's its own surface. Yeah, it's not, this surface isn't a datum or anything. This is just some control on its surface features here. Let me reset my no presets here. Oh yeah, so we've got to change this to, we're going to control it angularly. And the tolerance for that, I'm just going to push out to 10,000 here from datum A. So that's all that is. That's all we're controlling. I'll say okay, and I'll escape that command. I'm controlling that angle. So this is going to, what it means is if I have a dimension associated with that, and I have a dimension from datum A, 60 degrees, I'm going to then turn this into a basic dimension. So it's 60 degrees. I'm holding this angle to within 10,000. So let's just take a look at what does that look like on a model. I don't have that done in here, but what we're actually saying is that here's our datum A surface, and here's the surface we're controlling from essentially its orientation. Yes. And so angularly, when I'm applying this, it means that here's my theoretically exact place um, that this angle should exist, but I'm giving it a 10,000ths tolerance, and it's a plane tolerance that I give here. So it's not like an axis tolerance or yeah. So it's definitely there's no diameter sign in front of that. It's just a dimension given 10,000ths. And so what it does is if I take a plane, and I'm just going to offset a plane from this particular work surface. I'm going to select this as my surface. I'm going to offset it, not 10,000ths. I'm going to offset it pretty much 5,000ths in this direction and 5,000ths in the other direction from the theoretical exact place it could exist, like our model is the theoretically exact way we would like it. But to give the manufacturer a little room for error here, or we're gonna give them 10,000ths, which looks like that. But I'm gonna just say this half of the theoretical exact plane right there. So that's 5,000ths away. And then I'm going to offset a plane from that actually other plane, which is the limits kind of the entire tolerance here. So this would be a point 0, 1, 0. And is it going the right direction? I think it's going away, like further away from my feature. And really, this is the plane that kind of actually lives on the other side of the theoretically exact plane. So I'm going to make this a negative to drive that plane the other direction, and then I'll okay that. And this is what that geometric symbol is telling me as a manufacturer is that once here's datum A being controlled and or set down in our simulator to control it, and then I can measure this angle and really however that's been manufactured, I need it to fall between those two planes to be acceptable part. So I'm just requiring that it stays within that envelope there. If it varies a little bit, as long as it doesn't go one way or the other beyond this 10,000ths tolerance zone, it's an acceptable part. If it deviates from away from that, then it's a rejectable part. So that's kind of how I'd interpret what's going on there. Okay, so I'll leave that on my part though, actually. So that's what we've established. Now we're going to establish the next feature of size. I think the hole will be easier just because we did them on another, and we're just going to do a positional control on this hole. So let's see what the original document had. This one. So the control on the hole was just a positional control. Um, It doesn't have the dimensional tolerance given for the hole. I think I will express what's in the as a plus minus tolerance, what's actually assumed here. Um, I don't know, just because I think I can do the math when they're closer together, so I kind of like to see it. But I mean, I could be wrong on that, and maybe I'm over implying the same tolerance. But um, and this is a regardless of feature size tolerance. So it is a positional tolerance, and I'm going to control it with a diameter, so this kind of cylindrical tolerance zone down through it. I'm going to increase it also to just 10,000ths. I'm just going to bump my one the other way. So I've got a 10,000ths tolerance zone in there. And then it says from datum A. So I'm going to evaluate the location from datum A with this tolerance applied and see, here's going to be my theoretically exact dimension that can be, but I'm going to allow some positional tolerance there. And then in the other direction, according to from datum B, I have another location dimension that I'm going to apply the same tolerance, positional tolerance to. So I'm going to end up with a target that is just I'm going to call it 10 thousandths uh, zone. So, and I'll add the plus and minus onto this. So not anything really not the only thing changing is I'm going to add the plus and minus value to the dimensional value for the whole. And maybe that doesn't matter as much because this is a regardless of feature size. So I don't really get I'm not going to gain any bonus tolerance. Like no matter which you know, it's a half-inch hole with plus or minus 5 thousandths is essentially what the tolerance is applied. And those are my, so regardless, I have to hit that. Like that's one criteria that I have to hit. So it has to be, half inch plus or minus 5 thousandths. Um, and that's a rejectable size, or that's an acceptable size. Anything outside of that would be rejected. But that if that's an acceptable size, and then I can evaluate if the positional tolerance is within that spec too, where the center point of that circle lies. But I'm not going to gain any I'm not going to gain any added because I have no condition modifiers here, MMC or LMC. Then I'm not going to gain any additional bonus tolerance to the dimensional tolerance. So uh, yeah, I think I said that right. Maybe I said that backwards, but nope. Let's continue on and let's do this. So I need a datum feature symbol on this particular dimension. There's just one hole. Sorry, let's zoom in. And I'll just erase what I've got and start fresh here. So it is a positional tolerance. I am, it is a round or it becomes a cylindrical tolerance zone at 10 thousandths. So I'll say 10 thousandths. And first being evaluated from datum A, that'd be my primary datum. So I'm going to measure that location dimension first, and then I'm going to evaluate and its position from datum B. So this is definitely a precedence. A first, then B. I think I'm going to say okay. And I just said I was going to add the symmetrical tolerance to this, which is still, yes, 3 decimal places for that particular number, and it's going to be 0.005 for my. So it looks more like this. This just helps me kind of see what I've got to work with, and if I'm doing anything wrong there, it probably could be to omit that if it's being covered by this. So at least I'm aware of it. So there's my positional tolerance. Now let's just talk about those size and location dimensions. So the location dimensions are going to become basic or theoretically exact. So here is a location dimension. It needs to become basic. I think you can copy the properties from one that you have basic. Which one did I make it? This one? That might push the decimal place though. Let's see this one as its own basic. So now I've located with that dimension, and I've located with, I haven't actually, that's one dimension I missed, but I found it when I'm working through here, is I'm missing the location dimension here, right? Okay, and I will copy these properties and apply them there. And this is the other one, and I'll just pull my center line to meet my extension line. And this one is going to become basic as well. I think that's a copyable property here. Let's just see, copy properties and add it to here. Yeah. All right, so those are my theoretically exact location for that hole. And then we have one more feature of size, this little slot here. I can actually measure between it here, and maybe I can't totally measure between it here with between 2 points, but definitely in this direction I can. And so they do. So I'm going to apply the geometric control they have on here, GD&T control they have here. So it is well. So what we've got going on here is these are feature control symbols, feature control frames. Sorry, don't let me mess you up. Feature control frames, and we are going, and they are applied to an extension line off a surface, and so this is I think is a way for this to apply to that surface. So the feature control frame is applying to the surface that the extension line is away from, and that's probably, I don't know where that is in your text on that. Definitely they have the datum feature symbols in the surfaces. I'd have to look at feature control frames. And I should look at that because we've had a question on some of my leader line ones and yeah, I'll find that out. Some more deep study here because it matters. But I'm gonna use this same concept here And I'm going to just apply that these are also in that 10 thousandths range. So what they say is datum B is that left side surface. I'm going to control how parallel this is. Yep. It's going to be another orientation control. I'm going to control how parallel that surface is to datum B. And I need it to be within 10 thousandths as well. And so, and I'm going to control the other one from B as well, the other surface. Uh, and whether you could add a 2x and you'd have, I think there's other ways to notate this potentially. Um, I'm just going to do this, which is maybe it's GD&T 101, but that's great. I'm gonna at least I think I can interpret this correctly. So it's if I can at least not misinterpret it. But I think there's probably some more potentially. So here's my feature control frame. Let's see if I can add that. If I snap to this, yeah, I'm just snapping to that line. A grip that's on that line looks like I'm going to have no presets here. I think I can just slap it the other way once I get it done. But this is going to be a parallelism orientation control here. And I'm going to increase the tolerance. So it's not a diameter at all here. It's just a linear dimension or a tolerance between two planes that is 0.10. Sorry, point. I'm going to say 10 thousandths. And this is from datum B that we are kind of locating this and controlling that location, back that up, controlling that orientation. Just I only say that because that's where the geometric symbol that we're using, the geometric characteristic symbol, really lives in the orientation family. But I definitely get them confused between the locating geometric characteristic symbols and the orientation. So, so it's orientation from B. Okay, so that's it. That's the one we want. So I'm gonna say okay. I want to apply the next one, but maybe I'll just move this one out of my way. I think I can just grip this and flop it over and even extension. So I think I'm just going to stick it like this. And then I'm going to add my other one over here. I'll just snap it to that grip for a minute. It's the same tolerance I'm applying here. I'm sorry, the same control. Okay. So I think I can just slide this up now. Yes. Then I might just slide datum B over a little bit. Or sorry, datum A. It, just gonna eyeball, those are roughly the same. So there's two geometric controls. So all that says is, yes, same kind of plane, only if I put it here, it's the same tolerance. So it's like here, 0.005 or half of 10, and then offset the other plane. And I'm doing this control on both, so I'll say it's a minus 0.01. I'm doing that same kind of that's this parallel plane control on that theoretically exact size, and saying that actually that can live within this plane here, these two parallel planes. And the same geometric control applies to this surface as well. That's how we're controlling it, is between two planes. Okay, as long as it fits in there, as long as that surface lies in the between those, acceptable. And and then if I think of that a little bit, so I'm controlling this feature of size, and I'm controlling it with some location dimensions. So I've got a size dimension. It's this half inch. Um, one of these has to become like, of these three dimensions that are controlling kind of its location in this kind of X direction. I think one of these is going to have to give and become a reference dimension if they're all becoming basic, because it may not be unless maybe not, maybe not. Maybe they could all become basic. And I have to maintain that this is half inch, and I have to maintain that these are parallel to this tolerance zone and that they pull from B. And this hopefully the tolerance of this will allow that all to happen. But that's where I can wonder a little bit about these relationships of these three dimensions because I do feel like I'm definitely gonna make this one a basic. I'm pulling from datum B and locating to where this particular surface starts there, and then I've got that geometric control on that surface. And then from there, I go over to this next surface where I could have chained it together. So look, I could have probably controlled it like this, and it's arguable that I could maybe just drop it because otherwise I'm going to control it here potentially with a basic dimension, and then have kind of a baseline dimensioning, and let this kind of be. So this is going to have some more parts analysis to me to know what is the controlling dimension. So is it more anyway? So maybe I will on this particular one. Let's say that I'm going to drop this baseline dimensioning. That drops that symbol where my character. That's okay. I could drop this one pretty quick too. Let's zoom it in here. Find a grip. Snap it to. It's the same one. No big deal. Okay, good. Back to where we were. And I think I will say that I'll just put this one as a basic dimension then. And then I've got kind of the relationship that we've seen with just kind of locating holes and center to center of holes or something. So if I make these both basic, then I think that will work. They're kind of both locating dimensions. And this one's kind of almost double dutying as a size. And so then I've got a different, and then I've got this other surface of that feature that I need to locate it. It to me, it kind of functions as a size and location because it's kind of the size of how deep this is, but really maybe it's a location. Either way, it's something that has to be controlled from datum A for that feature of size. I don't have any controls over its necessarily the surface of it or anything. I don't have any, yeah, I don't have any uh, additional controls, but it is a location from a datum to a feature similar to these dimensions. So I'm going to turn this into a basic one as well. Either copy properties or just change it. And so now I say, I think I've sized and located this feature and it's got its geometric controls over it. And so I think that's it. And now we can move on to just a few other little details on this one. Surface finishes is it, right? It does have some particular surface finishes. We have kind of that is this a medium medium fine finish 63 micro inches, and here's a really getting quite fine. So we're requiring some pretty heavy controls over this. I'm going to apply. So here's another question because I have this broken surface. Do I need to apply the surface finish to both sides to be more correct? And when in doubt, it'd probably be better to apply them to both or put 2x. I think I'm just going to apply them to um, the both surfaces that could be interpreted as datum A. Yeah, I think so. So I'm not going to make any major changes. I might just add one for clarification and then, yeah, and then I might do some homework on the side and say, how do I specify that? So this side is going to be 125. Super, super fine finish here. I mean, it gets finer than that. We're asking a lot of work there. And which ones? I didn't memorize them all. 125, 63 there, and then 125 on the bottom. Okay. So this one here, I can't say how it applies this on a angled surface, something like that. I think that's the way I'll keep it, only it's a 63. Is that how my actually you're able to rotate that in CAD. I think I'll leave mine angled here. I didn't mean to open CAD either, but I can probably rotate this. And it might be in the tech in the might be the styles I need to go in and edit. Right now I'll just leave it. It's the one outlier that I've got that's kind of not reading horizontally. And then I'll apply two more. I got this surface here. It's going to be controlled, highly finished. And I'm just going to add this one just in case someone and I could have a discussion around this if I needed to ask. So I might just say, well, I'll move my datum feature. It's getting a little crowded. I'll just move it out to here. It's still the same, performing the same duty here. I've got plenty of an extension line here just because I've got to do a little bit of cleanup here. I just don't want to get it anywhere near that. When in doubt, definitely don't worry about my spacing. Worry about doing some wrong interpretation of datum here. Now I'll just refine this just a little bit. You can also like select one here and then say arrange. Am I right? A right click and say arrange dimensions. Maybe I've got to select them all and then say arrange. Let me see. Arrange. Kind of hooks them together at that spacing that's on the, should be quarter-inch spacing on this. And I'm just going to stagger this just a little bit more. Okay. Let me know if you think I've missed anything, but I think this is going to be my completed drawing. I've got height, overalls, only basic dimensions that are controlling features of size that are being geometrically GD&T controlled. So I think this is it. I've just got to just add a few things. Maybe I'll fill out my revision description. And I'll update the date for this, the 19th. It's the new year. I already filled out my title block with a few things. Got Rev 0, got my name. Yes, this is savable. So that's it for, that's how I feel like I'm going to end this one. Not too many changes from it, and then we'll do problem number 4 next.